Yeah. All right, number one, since the particle moves along the x-axis so that its velocity at time t is given by, and then I've got this nice little equation here for the velocity. At the time t equals 0, the initial position is 7. No. Welcome. Hold on. All right, the first one, this was calculator, y'all, so let the calculator work for you. I just simply found the derivative. I did inderiv. I put this in y1, inderiv at 5.1, and I got 6.492 was okay if you rounded it there, but that was just a one-pointer. There were no units there for anything. It was just find the derivative. You guys remember how to do that with your calculator? So I put this in y1 in my calculator. And then I did inderiv. Let me show you. Oh, guys. Yeah, this is strictly calculated. This should take you no time at all. I'm just putting this in. Connect to the third. Down in the rib, I'm going to pull up y1. I always put this in y1 instead of typing it in here because chances are this is just part A and I'm going to need to reference it again. 5.9. There you go. One whole point there. Number two asked me to find all the values in the interval, and it gave me this interval from 0 to 2 for which the speed of the particle is 1. So first of all, how do you find speed? Absolute value of velocity. If you put this, absolute value of velocity equals 1, you got a point for that. That was 1 point just for recognizing that speed and absolute value of velocity was the same thing, and you set it equal to 1. That was a point. That's why I tell you always write down, even if you're not sure that you know how to do it, write something down, because there, even if you didn't know how to solve it, you could get that. And then what I did, because it's between 0 and 2, I went into my y1 and I did a second insert, and I made it the absolute value of that. So I took that same equation that was already there from part A, right? And I went up to the beginning. If you do second delete, it lets you insert. You can't see it? Is it better? Okay. If you do second delete, that lets you insert something in front or wherever you are so it doesn't overwrite. You know what I'm saying? Yeah. Full time saving. But I did absolute value, and then whenever I did a zoom, whenever I did a window, I made sure to stay between 0 and 2 because that's what my range was there for my numbers. So I did a zoom 6 to start. How'd that get there? Yeah, and then I calculated where it crossed over, and notice that it's hitting 0 several places, but I got to stay between, or hitting 1. It was 1. Intersection. I'm only between 0 and 2. I could have adjusted my Y to make it. Yeah, because I wanted to know where does this equal this. So to know where this equals this, I need to I input both, and it's easier for me to calculate the intersection because that's just the second calculate, intersect, enter, as opposed to doing left hand, right hand. And if you notice, I did all of them to start with, and then I had to go back and cross it out because I went back and went, wait, I'm only between 0 and 2. So 1 point for setting the absolute value of velocity equal to 1, and then 1 point for the actual answer. There were 2 points. Is that good? You got this divided by 2? This one divided by 2? That's one of the answers. All right, part C. Part C was the big one here. Find the position of the particle at time t equals 4. Is the particle moving toward the origin or away from the origin at time t equals 4? Justify your answer. That justify your answer is a big part of the All right, so my position, of course, I need to do the integral of velocity to find position, but I have to add in my initial position. So for this one, this setup, for writing this integral, you got 1 point. For adding the initial condition to it, you got another point. So this right here gave me 2 points right off. Even if I didn't know how to find it, what to do, or how to plug it in, I got 2 points just from writing this part. Initial condition plus, or initial position plus the integral. Again, this is on your calculator, and this is still plugged in. I had to go in and take out my absolute value, so you just hit delete. And I'm ready to do the integral here. Integral of y1 x. What am I going from 0 to 4? And I'm going to add 7 to that. Something's not right with that. X to the 6th minus 13, x to the 4th plus, I got plus 1. I hope this gives me negative 0.288. And adding the 7 too. So then there's a point for the answer there. So far we're at 3 points, and there's a whole other point to be gained here. So these 3 lines are worth 3 points so far, which I thought was pretty nice. Then the last is the justification, and that's usually the hardest part. But since the position is positive and the velocity is positive, then I'm moving away from the origin. I must have missed that because there's an asterisk right. Let's see what they put. They put, their justification is the particle is moving away from the origin because x of 4 is bigger than 0 and v of 4 is bigger than 0. You got what right? The justification? You said both are positive, therefore it's moving away. You got to say both are positive, position and velocity. All right, part D. This was a tough test. No one was talking right. All right, during the time interval from 0 to 4, does the particle return to its initial position? Y'all had a lot of stuff on here for this one. I'm not sure that it was the same stuff, but you had a lot anyway. I started out this one doing the position at 0 and the position at 4. Because I knew that, and I took that from my prior problems. And then it says, does the particle return to its initial position? And then what did I do? S of 1. Oh, I wanted to see if the position was going up or down. And I said yes, because if it starts at 7, if you think about it starting at 7, it moves away to 9.4036 at time 1. And then it goes back to 6.7116 at time 4. So it has to pass 7 again through there. If it goes to, in other words, if it goes from 7 to 9 and then back to 6, it's had to have passed 7. Now, I said by the intermediate value theorem it has to cross back over. Their justification was a little more precise than mine, I guess. They said from time t equals 1 to t equals 4, the particle moves from 9.404 to 6.712. By the intermediate value theorem, the particle must return to 7 during the time. But to know that you had to look at the positions on either end to sandwich those values between, you got a point, and then you got a point for your answer with reason. That one was kind of tough, I thought. Say again. Why'd I do well? Because I had 0 and 4 from previous parts of the problem, right? And I wanted to see if it went from 7 to 6.7, what happens in between. So I just picked a random one. I could have picked 2 or 3, but I wanted to see if I started at 7, I went back to 6 point something, then where did I go in between to see if I cross over that 7? I feel like that was a terrible question. I feel like that part especially was awful. It doesn't become negative. But I think too, this was only 2 points for this one, and I thought it was pretty involved to only be 2 points. And maybe that's why they did that. It was kind of, you didn't take that initial position into consideration. I would say for that one, they're probably looking for that intermediate value theorem for you to say by the intermediate value theorem. Did you sandwich it between? Let me show you what they got. I might give you a point for that. Do yourself a point back. All right, questions about number 1. Y'all ready for number 2? I thought the calculator were harder than the non-calculator, if I remember correctly. All right, we have some regions here. Water flows into the tank at a rate of, and then I've got my A of t, and so that's my top curve here. And then during the same time interval, water flows into the tank at my B of t, so that's going into. Both are empty at time 0, so I don't have an initial amount there. I just start with no water in the tank. And it says how much water will be in the tank at time t equals 4.5. And I did go ahead, I shouldn't figure out what I did here, but I went ahead and labeled because they gave me these intersection points, right? I know this is K. I had a blank here whenever I must have figured that out in a later problem and went back and plugged it in. And this is 2.416 because they gave me those intersection points. I always come back to this picture to make notes on it as I go to try to help me out. So it says how much will be in the tank at time t equals 4.5. And so what I wanted to do was find A of t is the amount that flowing into. This is a calculator problem. Huh? All right, so at time t equals 4.5, I just did the integral from 0 to 4.5 of A of t. Oh yeah, tank A. I was sitting here going, why did I not subtract them? But it's 2 different tanks. So how much is in tank? And that was just on your calculator, 66. So you got a point for the integral. You had to show, this is the part where a lot of you didn't put the dt. And I'm not 100% if you get that point or not if you didn't have the dt. So be very, very careful about that. Why you have to put what? Yeah, they have to know what you're doing. You have to show your work. But they want to know what you did. Well, just think, what if you put it in your calculator wrong and you got the wrong answer, but you showed this? You get half credit. Did you get the right answer? Yeah. Go ahead, Madison. What? Because AFT is the rate. It's not the amount. So if it's a rate, I'm already, whenever you see the word rate, you know you're already looking at a derivative. So if I want the amount, I have to integrate. They didn't mention units here, but make sure you put them. Sometimes you get a point for that. Sometimes you lose a point for not putting it. So make sure you put liters. Barbara, I'm sorry, you have to put your integral. How, how much more specific would you like? What do you think it should say? I always assume they want to know how you got something. How about that? Write down everything you're thinking as you go. And if it's something that you think is wrong, cross it out. They won't grade anything crossed out. Better to have too much than not enough. There's always places to get little points here and there. That's why I tell you write something right. Okay. This is my second asterisk already, and I'm only on number 2. I'm only on number 2. So I must have struggled with this one. Huh? There's 6. I always asterisk anything that I missed a point on or that I struggled with. So I must have, and I'm looking at how that negative sign looks like it's written kind of aggressively, so maybe that's what I missed there. I don't know. During the time interval, water flows into tank B at a constant rate of 20.5 liters per. So here's tank B, 20.5 liters per hour. What's the difference between the amount of water in tank A and the amount of water in tank B at time t equals k? Okay, so what did I do? It's been a long time. B of t equals 20.5. That's my constant rate. I know that. So I needed to find out. It says the 20.5, so I need to find out when that equals A of t, because I need to find where these two cross over each other, where these two meet. So I did that on the calculator. And I always do an intersect here. I don't ever do equal to 0 and find the 0. I put 20.5 in y1, I put this in y2, and then I calculated the intersect there. I just think that's an easier, quicker way to do it. And then I did top minus bottom in my picture here. So I've got, this is 20.5, K 20.5, this is 2.416, and I don't have a value, but I'm going from 0 to K, because that's what it asked me. It asked me going from 0 to K. So top curve minus bottom curve, so it was B of t minus A of t, so that's why I put the negative there. Apparently I added it. And so I subtracted the 2. So it really should be this minus that. And you get 10.599. Yeah. It was 2 points, yeah. Nope, it was 3. 1 point for setting A of k equal to 20.5. I didn't do that. Oh, yeah, I did. That was 1 point. 1 point for the integral. It doesn't say which one, it just says for the integral. And then 1 point for the answer. right away. I did this one way different than they did. Let me show you what they did, because you might have done what they did. You did what I did? They set A of K to 20.5. They found the intersection, which was here. We found the same intersection. Then they did, they just combined the two integrals here. They did the same thing. I just made them two separate integrals instead of all in one. And they used the calculator. That K is what I had to find. That's that intersection point. That's up here. Yeah. I think that they had it defined, yeah, up here in the very beginning. It says, shown in the figure above, they intersect at P equals K and P equals this. So I knew, that was one of the first things I wrote. I put a K up here because I knew I'd get lost in the problem. So always try to label that picture if you can. Yeah. You want my integral or their integral? Huh? Their integral. They did the same thing, but theirs were, mine were switched. That's why I had the negative in front of A, and they combined it since it was the same thing. Make sense? These two were hard. I thought these two were terribly hard. Sure? Finally, one that I thought was a bit easier. It was only worth 2 points. The area of the region bounded by the grass y equals A of t and y equals b of t for, and then they give you this value here, is 14.470. How much water is in tank B at time 2.416? And so, what did we do here? Let's see. 14 point, I colored this in so I'd know what I was looking at. Okay, so if this is 14.47, they want to know how much was in tank B, which is this part down here, right? Does that make sense? So what did I have to do? I had to take from 0 to K, and then from K to 2.46 and add them together. And I did it this way because I had this value. This was what I didn't have. So I had to do top curve minus. In other words, if you do this whole thing, right, because I have an equation for that, I have to subtract out this 14.470 to find this because I don't have an equation for B. So if you do this area here, these 2 points, then what I've got is all of this area, and I have to subtract that out. So it's a little convoluted. It's kind of backwards of what we've done, which makes it a little bit hard. All right, and I came up with 48.3139. I'm so surprised this one's only worth 2 points. You got 1 point for going from K to 2.416 on A of T. This gave you 1 point, having that somewhere on there. And then 1 point for your answer. It was a lot of thinking, I thought. Because if you look at your picture, I'm going from here. Did it say, because it said how much water's in the tank at this time, so you had to take into account how much water from here to here was in there, and I'd already found that, and then add that to how much is what? The point breakdown? 48. All right, which one are you talking about? From 0 to 0.892 is 18. But then the other part is 2. And then part D asked you during the time interval from The rate at which water flows into the tank B is modeled by, and you've got this equation. So I finally have an equation for B. Is the difference WT minus A of T increasing or decreasing at the time of whatever? So to know if it's increasing or decreasing, I need the derivative. So I found the derivative of each of those at that particular point in time. They are both negative. If I subtract them, if I do this minus this, I still get a negative number, right? So think about your little sign analysis. Here's my derivative. What is it doing? If this is negative, then I am decreasing. So I said the rate is negative, meaning that the difference is decreasing at time 3.5 hours. It's the derivative. So you had to find the derivative. So I put this in a calculator, and then I said in deriv at 3.5. Then I did the derivative of A that I've already got in my calculator at 3.5, and these are the two values I got. So whenever I subtracted them, I knew, well, this minus this is still negative. So you got 1 point for this, and then you got 1 point for your explanation. Their explanation was the difference WT minus A of T is decreasing at T equals 3.5, which sometimes they want more, and so I don't know that that's enough explanation in my opinion. But, well, because if you subtract them, so negative 3.7860 minus negative 2, you still get like negative. This will give you negative 1.143, which is still negative. So, and this is derivatives I'm looking at, right? So if my derivative is negative, that means my function is decreasing. Yes, that's correct. Right. All right, let's look at number 3. If I recall correctly, they got a little better past the calculator part. So I'll do a little better here. A little more familiar anyway. All right, so these definitions in the beginning really help you out. So make sure you read through all the way, 3 line segments and a quarter circle there. So G be the function defined by, and I have my nice little equation here. Of course, y'all know I always go ahead and interpret, if this is the graph of F and G is the integral of F, that means this is the derivative of G. So make sure you know what you're looking at. That's the key for me to do. All right, so part A was the average rate of change from x equals negative 5 to 5. Average rate of change is just AROC. So I need G of negative 5 and G of 5. Well, G of negative 5, I'm using this little equation here, right? From 1 to negative 5, I flipped it around and put a negative in front, so my smallest was on the bottom, and I looked up at my graph, and I said, okay, from negative 5, and you see, this is one of the first things I do whenever I see something like this. I go ahead and mark my areas in here. It makes it a lot easier as I go through and try to find combined areas and whatnot as I go. So from negative 5 to 1 here. So I got negative 6, negative pi, and negative 1, but remember that negative that sits out front of everything. So it's going to be 7 plus pi. What did you do? Okay, so do you agree with these areas? Negative 6, negative pi, and negative 1. I came over here and did pi r squared divided by 4 because it said it's a quarter of a circle. Because this is, well, this means area under the curve. So this is area under the curve from negative 5 to 1. Okay, so if I'm finding g of, I use this equation right here. If I'm finding g of negative 5, I'm plugging in a negative 5 for the x. So from 1 to negative 5. Y'all okay there? If you did the difference quotient, like you knew A rock was difference quotient, like y2 minus y1 over x2 minus x1, they gave you a point for that. So that's probably why a lot of you got, even if you got this wrong, if you knew, you took whatever you got here, subtracted from this, and divided by, if you did that, you got a point. So that might be why you got it. This one was 2. So the difference quotient was 1, and the answer was 1. Yeah, okay. This was all, we've done a lot of these. This where they give you the graph of the derivative. B was IROC, find the instantaneous rate of change. That's just the derivative. That's all that is. So if I do the derivative, remember, this is the graph of the derivative. So the graph of, so derivative at 3 is just f at 3. So I just go to the graph and look, well, when x is 3, 1, 2, 3, what is my y value? And you should get 4. That's not, a lot of you said that actually, but this is the graph of the derivative. It's not the graph of the function. If this was the graph of the function and I said, what's the derivative at this point, you'd say it doesn't exist. But I'm not asking you for the, this is the derivative. So it has a specific value. Right. But that only counts, that tells you if the function is differentiable. If you're looking at the graph of the derivative, none of that counts yet. It's there. And that was only 1 point. Dang. Part C. This was 2 points only, and your 2 points all came in the same thing. It was, did you give the correct intervals with justification? And this is not justification. This helps me identify the intervals, but that is not the justification that they need. So remember, concavity deals with second derivative. If I'm second derivative of g, that's first derivative of f. So looking at your graph, you're looking at f, right? So I need to think about the derivative of that graph. So the slope, in other words. And so here's where I'm looking at, and I even made myself a note. I'm talking about maxes and mins of the derivative because I get confused. I have to start thinking. I have to picture it on an interval like this. So if you put your maxes and mins in here and you looked, you would find that, what am I looking for? Concave up. There's 2 intervals here where it's concave up, and that is because the second derivative, which is equal to the first derivative of f, is positive, therefore f is increasing, and so it's concave up. Did I mess up? Are you saying you should have gotten them because you missed it? And I'll show you, this doesn't have an answer, but this is, look at what they say. 2 points, intervals with justification. There's no breakdown on points there. I don't know why. Yeah. Okay. The graph is the derivative. So I'm looking for maxes and mins of the derivative. Right. So positive, negative, positive, constant, which was where I put my 0 here. So where is it concave up? I really feel like 1 and 2 just blew, it did mine anyway, it just blew my mind, and so by the time I got here, yeah. Only have you 1 on part C? You can't get just one, so I probably messed up. So put plus 2 and change it. Yeah. If you got it, you got it. If you didn't, you didn't. All right. I was ready to go spring break. Part D. Find all x values in the interval between -5 and 5 at which G has a critical point. Classify each critical point as the location of a local min, max, or meter, and justify your answers. Notice I thought I was working through this and I was like, golly, I am doing a lot of work here because I'm testing every place that the derivative of G is equal to 0. But you didn't need the endpoints because you're not inclusive there. So you don't have to test the endpoints. So the only thing that I have to test this point, and they're not asking, they're just asking for a local, okay? If they ask for an absolute, that's when you have to plug in like this. So I realized 3/4 of the way through the problem that I was doing way too much work than what they were asking. So I went back and went, you know what? They're asking for a local, not an absolute, which means I just need to look for changing from negative to positive. And so I found that there were 2 critical points because it says classify each critical point. So then that means I have to explain each one. Okay, so -2 is neither since the sign does not change. And 1 is a minimum since it changes from negative to positive. So for this one, you got 1 point for this, for considering f of x equals 0. That was 1 point. For just identifying these 2 critical points, you got a point, even if you didn't classify them correctly or justify correctly. And then your answers with justification were your final point. So 1 point, 1 point, and then these 2 make up a point. You justified it. You yourself. That's fine. I graded them quick, so you might find mistakes with that. Did you also say x equals 1? You said y? And tell me what you said at -2? Hey, you should probably get a point for that. Give yourself a point back. There's 3 total points. 1 point for considering where it equals 0. 1 point for identifying these 2, and then 1 point for the justification. Y'all adjust where you need to if I made mistakes, because I graded these. All right, number 4. Oh, I really don't like these table ones, but no points on this one? All right. Function satisfies f of 0, so I've got an initial condition here. Notice that for this one, I'm looking at the derivative. The first derivative satisfies the inequality that my derivative stays between 0 and 7. Closed interval 0 to 6, shown table above. Continuous second derivative for all real numbers. So it said use a midpoint Riemann sum with 3 sub-intervals of equal length indicated by the data in the table to approximate f of 6. So this is my, now remember this is the derivative, right? So if I do the integral, it's really just give me f of x. All right, so my Riemann sum with midpoints, this was nice because the midpoints were already there for me. I did not have to calculate anything. If I divided it into 3, there's 1, 2, and 3. So my midpoints are coming here, here, and here. Because it's, yeah. So the first one spanned from 0 to 2. So that's where the 2 came from, and then 3.5. Remember, these are just rectangles. They're not trapezoids, they're rectangles. Riemann sum means rectangle. It is RAM. Riemann sum is RAM. The only other thing that you might have to do is trapezoid, and it will literally say trapezoid. It'll say use the trapezoid rule. Then the second one will span from 2 to 4, which is a distance of 2. Midpoint's 0.8. And then from 4 to 6 is also 2, midpoint's 5.8. Again, this was no calculator, so technically you could have stopped there. If you did the midpoint sum, that was 1 point. Oh, wait. What woman? This stuff. This is f of 6, is what this equals. So because I'm going from 0 to 6, you have to think about taking that initial condition into consideration. This is the fundamental theorem because the integral from 0 to 6 is f of 6 minus f of 0. Because this is the, you cancel each other out. So, actually, no, I lied. This is not f of 6. This is the integral from 0 to 6 of the derivative. What did they ask me? Approximate f of 6. So you have to know that this is why I thought this one was difficult. You have to know that this is f of 6 minus f of 0. That's fundamental theorem of calculus. If you have an integral, if you ever end up in this situation, this is fundamental theorem. It says do f of b minus f of a. So that's where this equation came from and all this set up. And we find that f of 6 is 40.2. You got 1 point for the midpoint sum. You only got 1 point for all of that. 1 point for fundamental theorem of calculus, and then 1 point for the end. That one was tough. I could see you stopping here and not getting the rest of that.